All right, we're going to finish up chapter 5, and if we have time, finish up 6 also. Well, 6 only has 2 sections, and they're both the same stuff. So in chapter 5, section 5, we're going to solve logarithmic and exponential equations. Remember, logarithmic equations are inverses of exponentials. Equations. The conversion the base pushes up the answer, and you're left with the argument. Solving exponential equations. We have 2 possibilities that can occur here. If the bases are the same, the only way they could be true is if the exponents are the same. And if you have 2 exponential equations and the exponents are the same, then the bases have to be the same. So let's look at some examples here. Example 1. Solve 2, 3x minus 7 equals 32. So the steps is try to get the base as simplified as possible. That's the first step. I basically just put simplify base. This one's as far as you can go. How about 32? What is 32 made up of? Well, it ends in a 2, so we know it's divisible by 2. 2 goes into 3 once with 1 left over. 2 goes into 12 16 times. 16 is 4 times 4, which is 2 times 2, 2 times 2. So 32 is 1, 2, 3, 4, 5. Is 2 to the 5th. Since the bases are equal, then solve the exponents. For x. So since both bases are the same, we set the exponents equal to each other and solve for x. Add 7 to both sides. Divide by 3. And there's your answer. Then always remember, check your answer. How do we check the answer? Go back to the original equation. Put 4 in place of x. And work it out. So it works. Solving the logarithmic equations. If they have the same bases, if the bases are the same, then the operations have to be equal. So if log base a of m equals log base a of n, the only way that could be true is if n equals m. Right? Example 2. 3x equals 20. How would we solve that? So how are you solving it? What are you doing? Everybody's writing stuff. Because remember, the x is an exponent. The solution is that, how do we get rid of the exponent? Square roots, the nth roots only works if we have x and we try to get rid of the number. That's what I was trying to. We did that. Yes. Well, we know that the 3 is a what in this example? 3 is a what? 3 is the base of the exponent. So since 3 is the base, let's take log base 3 of both sides. Well, exponents go out in front. Log base 3 of 3 times x equals log base 3 of 20. What is log base 3 of 3? 1. They cancel each other out. This is the reason why. So if we have log base a of a equals x, so it's a to the x equals a. And the only way that could be true is if x is equal to 1. So x is equal to log base 3 of 20. If the computer won't take that as an answer, how would you get the answer for that? So you could do log 20 over log 3, or you can do ln of 20, ln of 3. What's that called? Let me give you a clue.
Oh, change base.
Yes. Change of base.
Seeing homework, so I know it in my brain.
It just popped up. Yeah, once you see that, then you know it's got to be easy. So whatever format the computer wants you to give it. Here, take a picture. Example 3. If you need to take a picture of it, I have to show here. This is like a spy school. Example 3. (100) e to the power 0.08 t equals 2500. So what's the first thing you got to do? First, you have to isolate the exponential term, which means we have to get rid of what? Get rid of the 100. Get rid of the coefficient, because t is right there. It's on the exponent. So we have to divide both sides by 100. That gives us e 0.08 t. The two zeros cancel, so we just equal 25. Second step is what? Here's our variable up here. How do we get it away from the top? Take the ln of both sides. Why ln? Because it's base e, right? So we take the ln of both sides. That means the exponent goes out in front. Bring the exponent in front, right? What's ln of e? What? Because ln is base e. Ln is log base e. So ln E is log base E of E. So we have 0.08 t equals ln of 25. Last step. To get the t by itself, what do we have to get rid of? How? Yep. Are you asking or telling?
I know, I was like.
Yeah, because they're multiplied, so it's opposite. So 0.08 on both sides. And you can put that in your calculator. And that's your answer. So far, so good. But example 4 brings a whole new problem to us. So we have 4 to the power x plus 3 equals 3 to the power negative x. It would be easy if we can get the same bases, but 4 and 3 do not have the same base. So if the bases are different, what do you think we do? No. Good guess though? No. Take the ln of both sides. You can also take the log of both sides, but ln is just going to be left to right. So we have ln of 4 to the power x plus 3 equals ln. Why did we do that? Is because we have to get the x's out of the exponent. So now this becomes x plus 3 times ln 4 equals negative x ln 3. So the next step is distribute. Get rid of the parentheses. Distribute to get rid of the parentheses. So we have x times ln 4 plus 3 times ln 4 equals negative x ln 3. Group like terms. So that means anything that has an x goes on the left side or any side. Since positive's on the left, I'm going to add x ln 3 to both sides and subtract 3 ln 4 from both sides. So those are gone. Those are gone. So I have x ln 4 plus x ln 3 equals negative 3. Bless you. ln 4. Isolate the variable. So how do we get x by itself? Well, since they're both terms have x's, we can factor out the x. And then solve. All we have to do is divide both sides by ln 4 plus ln 3. So x is equal to negative 3 ln 4 over ln 4 plus ln 3. And there's your answer. Type in your calculator and have it. Example 5. So what do you think we do here? We have a negative exponent here. So if we were to get rid of that negative exponent, the equation would look like this. So what do? We don't want to have denominators. So what do we always do whenever we have equal signs in denominators? Get rid of the denominator. How do we do that? By what? Yes. Find the LCD, which is right. Well, it would work this time because the numerator is 1.
Mhm.
If it was a number on top, we couldn't take the reciprocal. So we find the LCD, which is what in this case? E to the power x. Multiply each term by the LCD. So each term, we have e to the x times e to the x, e to the x times 1 over e to the x, minus e to the x times 6, e to the x times 0. Reduce. So those cancel. Multiply to get rid of the prince. So e to the x times e to the x is what? E to the 2x. Because remember, whenever you multiply the same bases, you add the exponents. E to the 2x plus 1 minus 6ex equals 0. And now we solve. We can rearrange these. So how do you think we'd solve this one? Yes, but we can't factor because what times what is one when you add them, you get six. So we don't factor what's the other method we can use. We can't use groupings, we only got three terms. Right, the quadratic formula.
Oh,
So we have e to the 2x minus 6e to the x plus 1 equals 0. A, B, C. Because what we're solving for is the middle variable. We're solving for e to the x. So it's negative b plus or minus square root of b squared minus 4ac over 2a. So what's a? In front of the e.
Oh.
1. B is negative 6, and C is positive 1. So just plug those in there now. We get negative of a negative 6 plus or minus negative 6 squared. 4 times 1 times 1 over 2 times 1. Negatives cancel. (36 minus 4 over 2). But 6 plus or minus 36 minus 4 is 32. 32 is made up of 16 times 4. Not 4. Excuse me, not 2. So 16 times 2, not 4. I really hosed that one up. 16 is 4 times 4, which is 2 to the 5th. 2 times 2, 2 times 2 times 2. Because there are 5 2s. Every pair of same numbers, so we have 2, and there's 1 2 remaining. So 2 of these will come out. 2 pairs. On top, I can factor out a 2. So far, so good. Now what do I do? What am I solving for? The x. I'm solving for x. So how do I get rid of the x? How do we get rid of the e?
Ellen.
Take ln to both sides, right? So the ln of e to the x, the ln of 3 plus or minus 2 square root of 2. The x comes out in front. X ln e ln 3 plus or minus 2 radical 2. So ln e cancels, it becomes 1. So we have one answer is ln 3 plus 2 radical 2, and x equals ln 3 minus 2 radical 2. How do we know if both of those are true answers? Whatever's inside here, remember the graph of an ln function looks like this. You cannot put 0 or negatives in there. So ln x only works if x is bigger than 0. Again, if you remember the graphs, what they look like, it helps us determine our domain. So as long as this number here is positive, we're in good shape. Since 2 radical 2 is close to 1 point something, 1.2, 1.3, which is less than 3 if I multiply by 2. So these are both going to work. So those are my solutions. Example 7 or example 6. So we have solved this one. Log base 3 of x equals negative 2. We're solving for x. So what do we do? Right. We have to use a conversion. Remember our conversion rule. The base pushes up the answer, and the log drops off. This is the conversion rule. Well, first off, we have to check, can your log answer be negative? Let's look at the graph. The log looks like what? Like this. Crosses through 1. So if I have a log, let's say log of 0.5, the answer is going to be a negative answer. I just cannot put negatives or zeros inside. X cannot be negative or 0. That's the only restriction I have. The y values can be positive, can be negative, or can be 0. That's why the graphs are very important, which is why I gave you the library of functions so many moons ago. So let's convert this. It becomes what? 3 to the power negative 2 equals x. So x equals what? What do you do with negative exponents? Turns them into a fraction. Yes. So this number now goes on the bottom, drop the negative. Very good. So it becomes 1/9. That's my x value. Example 7. Log x plus log x plus 3 is equal to 1. Again, these are using the properties of logarithms. What property is this one using? The multiplication, the product, right? The multiplication, the product rule says this. The log of m times n can be expanded to the log of m plus log of n. Remember, you can go both directions. So I gave you log x, they're the same bases, and they're adding, so I could put them both together. X times x plus 3. Now I got to, what's the base here? Base 10. So it's 10 to the first equals x plus 3. So 10 is equal to x squared plus 3x. It's quadratic, so it has to be equal to 0. So I subtract 10 from both sides. Yep. Because what does the second sign mean negative mean?
Okay.
The signs are going to be different. One's positive, one's negative, and the bigger one's positive. So you're right. What times what is 10? When you subtract them, you get 3, 5, and 2. Which makes my answers what? -5 and +2. Is that my answer? No. Let's check your answer. Right. Because, well, it can be in this, but if I put -5 into both of these, they both become negatives. So if this one was an 8, I could put -5 plus 8. It'd still be positive. It's just that this one here is, so if I had an equation that was x plus 7, x plus 9, right. This is when everything's said and done, you cannot have a negative there. So I cannot put -5, so I can't use -5. The only one I can use, my answer is x equals 2. That's my only solution. Because you always have to check your answers. Again, so any questions about why I cannot use -5? Because if I plug it in there, it's x is negative. Remember, I cannot use negative inputs. Example 8. Log base 3 of 2x minus 1 minus log base 3 of x minus 4 equals 2. It's a quotient because the rule we're using here is this one. Since it's a subtraction, one's positive, one's negative, then I could combine both of these as a rational equation. Okay, so that's using the properties. Now what do? I use the properties to combine them. Now I gotta do what? That's first step. Now, what do I do? No. We're not there yet. We're doing a conversion. We have to get. How do you get rid of the log? To get rid of its base. The conversion. So we have 3 to the power 2 equals 2x minus 1x minus 4. By using the conversion property. Now we solve for x. So 3 squared is 9. 2x minus 1, x minus 4. Then what? By, right. Since we have a fraction and an equal sign, multiply both sides by the LCD, which is the denominator. So 9 times x minus 4 is equal to 2x minus 1. Get rid of the parentheses. Move all, combine like terms, so it can move all the x's to one side, all the non-x's to the other side. 9 minus 2 is 7x. 36 minus 1 is 35. And solve for x, divide by 7. So it equals what? Are we sure that's the right answer? Always check your answer. So I'm saying that x is equal to 5. Just plug in anywhere you see an x, plug a 5. Yeah, in other words, the equation has to be true on both sides. No, put that up. You don't need it. Trust me, you don't need it. No, let's do it step by step. 2 times 5 is 10, minus 1 is 9. 5 minus 4 is log base 3 of 1 is equal to what? There's a property that we talked about that log of anything of 1 is equal to 0. So that goes to 0. So we have log base 3 of 9 is equal to 2. Do the conversion. 3 to the power 2 equals 9. So that works. You're going to use a calculator. And then question number 9, example number 9. We have ln of 4x plus 6 minus ln x plus 5 equals ln x. Okay, so what do we do? Well, yeah, because we combine these when we can. This is, since it's a minus, we have the quotient rule, which is 4x plus 6, x plus 5 equals ln x. Well, we can use one of two rules here. One rule we talked about, if the logs are the same, the only way they can be this equal is if the operations are equal. So it could be log, it could be ln, doesn't matter what it is. But there's another way we could have done the same thing. We could do, since they're ln, which is log base what? E. We could take the e of both sides, which makes these exponents. So we have 4x plus 6, x plus 5 equals x. Because e to the power ln cancels out. Because there's a property we talked about first that said as long as you have the same bases here and here, the answer is whatever the operation is. Since we have e ln x and e is log base e of x, the answer is x, since the e and the log cancel. It all goes back down to the basic rules. You have to be able to apply the rules. As long as you can apply the rules, whatever happens, happens. Now we just got to solve for x. Multiply both sides by the denominator. And solve for x. Get rid of the parentheses. You really shouldn't have to bobblehead from here on out. You should be able to solve it yourself now, if you learned anything this semester. So what's my first step?
Six.
Yeah, so subtract 4x and the 6 from both sides.
Hmm.
5 minus 4 is 1. Then we can factor if possible. What about the signs?
It's gonna be positive.
They're both. So what times what is 6? When you subtract them, you get 1. And the 3 gets positive. Very good. So when I solve those, I get what? Then we have to check them. Very good. And you have to always check them on the original equation. So can we look at one, see it doesn't work already? Well, I would have said because you have ln -3 on this side. Yeah, right. So -3 cannot work because you cannot have an ln of -3. You're right. The other side would have been -12 and plus 6 would be -6. But let's check the other side. Ln of 4 times 2 plus 6 minus ln 2 plus 5 equals ln of 2. 8 plus 6. 5 plus 2 is 7. Ln of 14 minus ln of 7 equals ln of 2. Since they're subtractions, 14 divided by 7 equals ln 2, which equals ln 2, so it works. Because if you plug in 2 in place of the x's, you have 4 times 2 is 8, 8 plus 6 is 14, 2 plus 5 is 7. Since it's subtracting, I divide these. 14 divided by 7 is 2, so the ln of 2 is ln of 2, so it works. End of chapter 5.